Let us look at depressing a polynomial equation. Now, another useful transformation is to transform an equation into an equivalent one in which a chosen term has been eliminated. Let's see how to do that. We have this equation f sub n of x equal to 0, where a sub naught is not equal to 0. So now let us carry out a translation transformation of the variable x so that the roots get shifted by h. So y is equal to x minus h, which implies x is equal to y plus h. So what are we going to do? We are going to substitute or replace x in this equation with y plus h. We get this equation. Now, expanding and collecting like terms. Let's very briefly look at an example. As a reminder, let us expand and collect like terms for y plus h plus h square plus y plus h cube. Now here, this notation within brackets n and 2, that is the combination NCR, which is equal to n factorial by r factorial times n minus r factorial. Now let's actually look at this with an example. So let us expand and collect like terms for y plus h square plus y plus h cube. We get this expansion. So here 2, 0 combination will give us 1. 2, 1 will give us 2. 2, 2 will give us 1. Here it will give us 1, 3, 3, 1. So simplifying that, we get this expansion, and simplifying that, we get this. And now we collect like terms to get this form. So now here, of course, we have taken specific values for the powers. But here, this is general. And that is why we don't literally have to go all the way, because it could be 1000, 2000, whatever. So we go only up to that term which we are interested in. So we stop at the term we wish to remove. Now, whichever term needs to be removed, we equate its coefficient to 0, except the term a sub naught y to the power of n, since a sub naught is not equal to 0. What does this mean? If we want to remove the second term, we equate the coefficient to 0. If we want to remove the third term, we equate this to 0. So removing y to the power of n minus 1 term, that is the second term here, we equate the coefficient to 0. n a sub naught h plus a1 is equal to 0. And we solve it for h. We get h is equal to minus a1 by n a sub naught. So here, if we replace h with this expression, what will happen? The second term will disappear. So this eliminates the y to the power of n minus 1 term and produces a depressed polynomial. Now let's say we want to remove the third term. We equate the coefficient of y to the power of n minus 2 to 0. This is a quadratic in h. We have h square, h and constant. So it's a quadratic equation in h. So on solving for h, because it is a quadratic, we get two values, which implies two transformed equations. Let's say equation 1 and equation 2. Now equation 1 and equation 2, both are equivalent to f sub n of x. Both eliminate the y to the power of n minus 2 term. Equation 1, equation 2 correspond to different translations of the variable. Hence, they have different coefficients. So equation 1 is not equivalent to equation 2. Now, what happens when removing y to the power of n minus 3 term? If we follow the same logic, we get a cubic equation in H. On solving for H, we get three values and hence three transformed equations. In practice, we are usually interested in removing the y to the power of n minus 1 term because it requires solving a linear equation. Think about it. How about removing two terms? Terms with, let's say, y to the power of n minus 1 and y to the power of n minus 2. What happens then? Try to figure this out. So this is a pretty nice technique which we'll be using in the next session itself of depressing a polynomial equation. That's it for now. Bye.